This is R.D. Sharma's solution. We are taking probability chapter and second exercise. Now from a pack of 52 cards. So in a deck of cards, there are in all 52 cards. 2 are drawn one by one without replacement. So we'll take or pick one and then second one without replacing the first one. Find the probability that both of them are kings. Now in this question, there are 52 cards, 26 are black, 26 are red. And in this 26 and 26, there are 4 suites. Actually, there are 4 suites in 52 cards. 13 are spade, 13 are club, and they are differentiated by the symbol or the diagram they have on each of the card. Red category, again, we have 13 diamond and 13 heart cards. Each of them means each of the suite will have 1 ace, 1 king, 1 jack and 1 queen. So in all there are 4 kings because there are 4 suites. First we have to create the events. Let's start with A. The king's first card is king. That is, if we draw the first card, king comes. Now without replacing the first card, the second card again comes as a king. So this is the question being asked. In the similar manner, we will make the events. A is a king. In 52 cards, there are 4 kings. So the first event is a king is drawn as a first card. Let's make the second event because both of them are going to be kings. So B will be a king in second draw. Now A probability is quite easy. So probability of getting a king in the first draw. The probability is a number of favorable cases divided by total number of cases. So what are the total number of cases? 52 cards. So 52 number of possibilities are there. One card can be taken up from random 52 cards. But there are 4 kings. So the king only the favorable cases are 4. It is 1 by 13. This is probability of getting a king in the first draw. Now we are picking the second card. But remember, the first card is not being replaced. So 4 card, 1 is already been drawn, only 3 are left. Now the probability of getting a king in the second draw, known that, or if it is given that the first card was king, that is A is known. So what is the probability of B, getting the king in the second card? So getting a king in second draw, knowing that, or if it is given that the first draw has given us a king after getting king in first draw. So this is a conditional probability because in conditional probability, you know certain thing and then you predict the or estimate the second thing. Now you don't have to worry about PB by A because it is simple that one has been drawn, one card. So 51 cards are left. So now the total number of cases will be 51. One has been drawn. It can be any card. We don't want to know right now. Total number of cases are 51. But when we want to know about the favorable cases, one king is already been drawn from the 4 king available. So only 3 are left. So the next card, king, can only be one of these 3 if at all it happens. So 3 by 51. 1 by 17. So what is the required probability? What is the probability that both of them are kings? Both of them are kings. What does it mean? P, A intersection B. A and B are the 2 events we made, and the intersection of these is first and second card should both be kings. So P A B by A is P A intersection B divided by P A, and P A intersection B has to be computed, and this will be equal to, we multiply the denominator with the left one, so it will be P B by A multiplied by PA. PB by A is just a conditional probability which came 1 by 17. PA came to be 1 by 13. So 1 by 13 into 1 by 17 gives us 1 by 221. So if the first card comes out to be king and we want the second card also to be a king, the probability of getting both the card as king is simply 1 by 221. Now how this will be done is in front of you. And all these things have to be written because in probability writing is very important. From the pack of 52 cards, 4 are drawn one by one without replacement. You are not replacing it. So the actual number of cards will get reduced. So first card we have drawn, didn't put it back. Second card, didn't put it back. Third card, fourth card, same way. So no replacement, 4 cards are being picked. Find the probability that all are aces, all are kings, all are jacks, all are queens, all are twos, all are threes, all are sevens, all are tens. Why I spoke on all this in one sentence? Because all of them will follow the same logic, same reasoning. So twos, 4 true twos are there. Queens, 4 queens are there. 4 aces, 4 aces are there. 4 kings, 4 kings are there. We'll start with the event making. So A will be first card drawn is an ace or a king. Let's stick with ace. B will be second draw, again ace. B, second draw, ace. Same way C, third draw gives us ace, or third draw comes out to be an ace. D, the fourth draw is coming as an ace. It can be king, it can be jack. Again, I'm re-emphasizing that the same logic, same reasoning will work for this question, whether it be aces, kings, queens, or jacks, or any of the number in the numbered cards. What is the probability of getting an ace? There are 52 total number of cards. The total number of cases or possibilities are 52. Any one card can be drawn. But the favorable case, because we definitely want ace to come, and since there are 4 aces, one of the card from the aces can be picked. 4 are there. So we have total number of favorable cases as 4. Next is PB by A. What does it mean? If the first card came as ace, what is the probability of getting again an ace in the second card? So since we have not replaced, there are 51 cards left and we have already picked an ace, so only 3 are left. So 3 by 51 is the probability of getting the second ace. Now, what is the probability of getting a third ace? Provided that first and second gave us aces. So probability of C, and given that A intersection B is simply that first and second was already an ace. So 2 cards have already been drawn, only 50 are left. 2 aces are already been drawn, so only 2 aces are left. So 2 by 50 is the probability of getting third ace, provided that the first and second are already ace. Now probability of getting the fourth ace. First and second and third are aces. They have already come, or we have already got 3 aces. What is the probability of getting fourth ace? So the total number of favorable cases, because already 3 has been drawn, 52 minus 3 is 49. 49 are being left, and since 3 aces are already been drawn, only 1 ace is there. So the total number of favorable cases is only 1. 1 divided by 49. Now what is the probability that all are aces? So P A intersection B intersection C intersection D is going to come. A, B, C, D all intersected. That means all of them are aces drawn one by one without replacement. So PA into PB by A into PC by A intersection B into P divided by D divided by, or not divided by, it's by A intersection B intersection C. So let's multiply all of them. 4 by 52 times 351 times 2 divided by 50 times 1 by 49. So 4 by 52 is simply 1 by 13. 3 by 51 is 1 by 17. 2 by 50 is 1 by 25. 1 by 49 remains like this. Just multiply all the numbers in the denominator, you will get a big number, and that is 1 by 270,725. So probability of getting all the aces one by one when 4 cards are drawn without replacement is this number. Now this is the formal way of doing it. If you are writing, you need to write in this clear manner. The concept, I hope, is clear to you. Find the chance of drawing 2 white balls in succession from a bag containing 5 red and 7 white balls. The ball first drawn not being replaced. What does it mean? Let's see diagrammatically. There is a bag. In this we have 5 red balls and then 7 white balls. This is 7 white. Now in all there are 12 red plus white balls. So in all 12 number of balls are there. Find the chance of drawing 2 white balls. So 7 white balls are there. We need 2 white balls in succession. That is, first ball should come white. The second ball also should come white. But please remember, there is no replacement. So we are making the event A is white in the first draw. We get a white ball in the first draw. Then we are getting or hoping that white ball comes up in the second draw. So not replacement is a key here. So what is the probability of getting a white ball first time. 12 balls are there. There are 7 white balls. So one of the ball in 7 can come as white ball. So 7 by 12 is the probability of getting a white ball in the first draw. Then probability, if it is known that first ball has already come as white ball or picked up as a white ball, what is the probability of getting the second white ball? So P B by A. So this will be simply because one ball has already been taken out, so only 11 ball is left. In 7 balls, one has already been taken, only 6 white balls are left. So total number of cases are 11 and total number of favorable cases are only 6 now. 6 divided by 11 is the probability of getting a second ball if it is known that the first ball is already white ball. So we have PA intersection B, that is both the balls should be a white ball. So PA intersection B, we know the formula, so I'm writing it directly. PA intersection B is PA into PB by A. What is PA? It's 7 by 12. What is PB by A? If it is known that one is the white ball, first one is the white ball, and the second also comes up to be the white ball, that is 6 by 11. So 6 2s are 12 and 7 divided by 22. 7 by 22 is the probability of getting 2 balls in succession. So this is the way we are going to write this solution, you can say. And writing is very important, and knowing the formula up front is also advisable. A bag contained 25 tickets numbered from 1 to 25. Again, let's see it diagrammatically. We have 25 tickets. So these are representing tickets 1 from 25. Just assume that all these tickets are being marked here. So in all, the total number of cases are 25. A ticket is being drawn, and then another ticket is drawn without replacement. So we have taken out a ticket now. Okay. First ticket, call it as T1. Let's call the other one as T2. Now both the tickets which are being drawn should be an even number. So let's make certain events. Actually, there will be 2 events. The first one will be the even number in the first draw or first picking up, then even number in the second draw. Even number are those numbers which are divisible by 2. What is the probability of A? How many total possibilities are there? 25. Now what is the favorable case? Favorable cases are only even numbers. So we just have to count the even possibilities. Even numbers are 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22 and 24. So these are the numbers, even numbers lying between 1 and 25, inclusive of 1 and 25. So there are in all 12 favorable cases. Now probability that A is known, even number has come already in the first draw. What is the probability of getting the even number in the second draw? One ticket has already been drawn. So the total number of favorable cases has reduced from 25 to 24. This is 24 in the denominator. Now in the even number, one has been drawn, because the first A has already been completed. So only 11 possibilities are there. Any even can be drawn at the first picking up. Now 11 by 24. Both the tickets are show even number. That means we have to intersect these two. PA intersection B is PA multiplied by PB by A. PA is known as 12 by 25. PB by A is 11 by 24. Let's cancel this out. 11 by 25 into 2, that is 11 by 50 has the result. This is the ticket, both the tickets from 1 to 25 coming up as even numbers. And this is the way I always project the reference for you so that you know how to do it and how to write it together. From a deck of cards, 3 cards are drawn one by one without replacement. First card, then second card, then third card without replacement. Find the probability that each time it is a card of spade. Now it can be a spade because there are 4 suites, but the same question goes along or is true if this spade is replaced by clubs or replaced by diamonds or replaced by hearts. So all the logic remains the same. So first draw, A is saying first draw is spade. Second draw, again a card from this suite of spade. C, third draw coming up again as a spade. Now probability, one more thing here is there are 52 cards, and how many spades are there? There are 13 spades. See, 13 spade, 13 club, 13 diamond, 13 hearts. In all 52, it is divided into 4 suites. So 13 in all, 52 total number of cases, 13 favorable cases. Now, probability of getting again a spade, if it is given that the first has turned up as spade. So 51 is left because one has been drawn. In 13, one has already been drawn. So only 12 spades are there. So 12 by 51. The probability of getting the third spade, if it is known that the first, second has come from the same suite, which is spade. So only 50 are left now. 50 total number of cases, and in the spade 2 has already been drawn. There are 13 spades, so only 11 are left. So just subtract 2 from 13, it will be 11. So these are number of favorable cases. So probability that each time it is a card of spade, just multiply these. So P A intersection B intersection C, that is all of the three are coming as spade, is PA multiplied by P, B by A multiplied by P, C by A intersection B. P, all of them are spade. So 13 by 52 is 1 by 4. 12 by 51 is 4 by 17. 11 by 50 is not divisible, so let's write it like this. 4 can be cancelled. 11 divided by 850. So 11 by 850 is the final probability. This is how you are going to write it. Okay, it's an easy question if you are aware what are spades, club, diamonds and hearts. This question will be taken in the next discussion. Till then, thank you so much. Have a good one.